Welcome back. In this video, we'll be talking about set builder notation. In some previous videos, we've already discussed two different ways to define a set. We can write down a description of the set using words, or we can write a list of the elements of a set. So that's the roster notation. A third way to define a set is called set builder notation. And so here's the idea. Out of a universe of possible objects, we can specify which of the objects are members of the set. So let's look at this example. Consider the set of non-negative integers that are multiples of 3. Okay, so we see that the universe of possible objects is the set of non-negative integers. That's where the possible objects can come from. But of that total universe of non-negative integers, only some of them fit in our set. And that rule is that they have to be multiples of 3. Those that are multiples of 3. Okay, and so you can see here we're given the precise rules for how to build the set. And that's why this is called set builder notation. Alright, so here we've written out in words, but often when you're dealing with set builder notation, you'll see the objects using mathematical symbols. Let's see that in action. First, let's talk about some notation that you will see regularly, and so it's important that we can read it and use it as we go along. So if you see a colon you should read as such that. And some people like to use a vertical bar. That also means such that. There's this fun backwards E, and you should read that as there exists. And here's an upside down A, which means for all. And then there's this figure that points upwards, that's an and then there's this figure that points downwards, kind of like a V, and that's an OR. Those are some symbols that we'll run into. And let's remember that we wanted to talk about non-negative integers that are multiples of 3. So let's see some ways that you could write that down in symbols. We can read this first line as x is in the set of natural numbers such that x is a multiple of 3. This second one, you could read, we're looking for the set of x such that x is in the natural numbers and x is a multiple of 3. This third one is mostly words. We can read it. The set of x such that there exists a k in the natural numbers for which x is equal to 3k. Right, we would want x to be a multiple of 3, so it's some number times 3. And if we wanted to put that fully into symbols, we could have the last line here, which says exactly the same thing. The set of x such that there exists a k in n for which x is equal to 3k. My personal preference is to use fewer symbols and more words because I feel like it's a little bit clearer. So why might we decide to use set builder notation instead of roster notation? As mathematicians, you've seen before we like to be very precise with our language. We don't want there to be any room for misunderstanding. So let's say we wanted to write this set, the set of all multiples of 3. In roster notation, we might start writing the set that contains 0 and 3 and 6 and 9 and 12 and 15. And we can't just keep writing forever. There's infinitely many things to write down. So we might put a ... Now, it's not always clear what the ... means, which means the roster notation can be less precise than set builder notation, especially for these infinite sets. One of the things that you're going to get some practice with is converting between notations. So let's say you have something written in set builder notation and you'd like to write it in roster notation. Since it's in set builder notation, it's normally written in terms of symbols or a combination of symbols and words, so you need to translate the expression from symbols into words first, use that to figure out what is the universe of possible objects, and the rule that determines whether an object is in the set or not. Test some objects so that you get a chance to understand what this rule actually means, and use that to determine the pattern of objects that are in the set, and then write those in roster notation in an organized and unambiguous fashion. If there's infinitely many, you need to use the ... but make sure it's clear what that ... means. Alright, now let's say you're going back the other way. Let's say you have something written in roster notation, and you want to write it in setbuilder notation. Since it's in roster notation, you'd want to understand what's the pattern of elements in the set. Once you understand that pattern, then you can start to say, okay, well, what's the universe in which the elements lie? And what's the rule that completely describes the membership criterion? What is the rule that says this element should be in the set and another element shouldn't be in the set? And then you translate the rule and the universe into symbols so that people can read it in setbuilder notation. Let's look at an example. So here's an example. Let's write the set S in roster notation. Okay, so the first thing we need to do is, this is fully in symbols, so let's translate it into English. So this is the set of integers x such that x plus 3 is a natural number. From this, we need to determine what the universe is and what the membership criterion is. So the universe is that x is an integer. So we're only going to consider x's where x is an integer. But what makes x a good integer versus a bad integer? Well, this membership criteria right here is that x plus 3 is a natural number. Okay, so we understand what the universe is, we understand what the membership criterion is, so the next thing to do is determine what elements are in this set. Well, if x plus 3 is a natural number, well, x plus 3 could be equal to 0, or x plus 3 could be equal to 1, or x plus 3 could be equal to 2, or equal to 3, etc. So we could use that information and solve and say, oh wait, this is the same thing as x is equal to negative 3, or x is equal to negative 2, or x is equal to negative 1, x is equal to 0, etc. Hey, so what's this pattern? Well, the pattern sure seems like it starts off, and we could say we're allowed to have negative 3, we're allowed to have negative 2, we're allowed to have negative 1, 0, 1, and that's probably enough to convey what the roster notation is. We basically have all integers that are greater than or equal to negative 3.